Diodes are extremely useful electrical components used in a wide variety of situations. In a circuit diagram, you draw them something like this. A standard diode is an arrow pointing into a line. Sometimes that's filled in. Now, diodes are basically one-way valves for electricity. A current, that is to say a conventional current, can flow this way through a diode, but it can't flow that way. As such, they're very useful, for example, in converting alternating current into direct current or something like that, because it only lets electricity flow one way. So enormously useful things. I won't go into how they work, because that's rather complicated and involves quantum mechanics and semiconductors and doping and all sorts of things like that, but you can look it up in many websites and textbooks. A crucial parameter for a diode is its what's called IV diagram. This is a plot of the current through the diode against the voltage across it. Now, for a typical silicon diode, if there's no voltage across it, no current will flow. If you start putting a small voltage this way across it, to begin with, nothing much happens. But when you reach a voltage of about, for silicon, 0.6 volts, you start getting a current, and it rapidly increases as you increase the voltage beyond that. In fact, that's a little dangerous. If you let the current go over about 1 amp, you can melt your diode. Not a good idea. If, on the other hand, you apply a voltage in the other direction, you don't get a current. Nothing flows, nothing flows. You can make a bigger and bigger and bigger and bigger negative voltage, and nothing flows. This is what I mean by a one-way valve for current. Current can go this way, but not this way. Note, this is conventional current. The actual electrons are going the other way around. Now, is it perfect? No. At some point, when you get to a very large negative voltage, typically between 100 and 1000 volts, it'll break down and let current go the other way. Often huge amounts of current go the other way. And this, for normal diode, is a no-no. You don't want to do that because it also melts your diode. However, there is a particular type of diode called a Zener diode, where this behavior over here is actually deliberately used. So the Zener diodes are much like normal diodes, except they're designed so they don't melt at this particular situation unless you make the negative current too large. And they can be used, for example, as a voltage reference, because what you'll see here is you get the same voltage for a range of currents. So what that means is you actually can deliberately drive them to a negative voltage till they're in this range, and then no matter what the current is, the voltage will always be the same, so you can use it to stabilize your voltages. So Zener diodes are quite useful because they have the same behavior as all normal diodes, except they're designed not to melt in the process unless you make the current too large, and they can be used as a reference source.